Hello and welcome to another Solana tutorial. Today I bring you my favorite topic again, transfer hooks. I have talked about this before and I will talk about this again today because last time when we talked about it, I basically just gave you an intro to what token hooks are, but we didn't really build nice token hooks, right? We did one simple example, but today I really want to build like 5 different versions of a transfer hook, like write a program that implements the interface for token extensions transfer hook to call our program correctly with different accounts. So we're gonna do this in different levels of difficulty, starting fairly easy and getting more complicated along the way. We'll see how far I get with this. My goal is 5 different versions today, so we actually build transfer hooks that you can actually use, like that are somewhat productive, or at least I give you the idea of how to actually build it. I do expect that you have watched the video from last time, so I'm not going to go through what a transfer hook is again. I expect that you have that knowledge already. This is my favorite topic because it essentially lets you do whatever you want to do with tokens, and so I just keep making videos about that because that's just so cool. And it will probably not be my last video about transfer hooks. We definitely still have a lot to look into, so let's get started. But I do want to start with a little bit of a recap on what we did last time, just to get you up to speed. Last time, we implemented a super simple transfer hook. Basically, it just allowed us to transfer dust. That's what we did. So we checked the amount, and if the amount is larger than 10, we didn't allow the transfer. But what the hell is this? Where am I here? This, ladies and gentlemen, basically we're in the Solana program library token transfer hook. That's what we find there. And just in case stuff changed and stuff changes, yeah, I'm just gonna clone the entire SPL again. So token and then transfer hook, that's what we open. Now in transfer hook we should have this example program where in the processor, in the process execute, here that's where we added our stuff, right? Our custom checks. Let's not allow 0 token transfers, and otherwise just say thanks for using our transfer hook. So this is our version 0 now, just to see if we can get the transfer hook to work again. So what do we need to do in order to deploy this? Cargo build SPF, waiting for file lock on package cache. Yeah, so it looks like I have some kind of a lock. Again, waiting for a lock. Oh, we have it. We have it. Yeah, Rust Analyzer or something is... What? Are you building it again now? I'm probably not just building this example. I'm probably building the entire SPL. Is that what I'm doing? There we go. Build another thing. Sure, why not? There we go. Finally, we get to the thing that I wrote, because that's now invalid because I added some stuff and I didn't include this crate. That is true. So, cargo, add me this error, please. There we go, different error. Missing documentation for an enum. The lint level is defined here. Missing documentation for a variant. Linting, man. Linting, by the way, is it checks if the source code look good, right? It's not that it doesn't compile, it's that it doesn't have the right formatting, it doesn't have enough documentation, those kind of things. It doesn't have spaces instead of tabs. That's all linting, in case you've never heard that term. So a linter checks that, and my linter tells me that I need to document my frickin' what do you want, like error for when the transfer through fail. What the do you want me to write here? Is that what you want? Yeah, that is what you want. Okay. Yeah, freaking force me to write documentation that is bullshit. But it compiles now. I can understand how Solana Labs has those kind of linter rules for their programs, because for the SPL it totally makes sense. For my quick little hacky scripts, it, I don't know, doesn't make that much sense, but at least we saw that that's a thing that they do. Okay, cool. Moving on to back here. Since this compiles, I should now have a target somewhere, probably far outside. Let me check. Oh, here it is. The transfer hook example. That's my program. I mean, obviously, if I were to build a proper transfer hook, I would, build my own program and not work with this example. But I'm being lazy and I don't want to build my own thing, so I'll just do this. Today we talk about how to build different kinds of transfer hooks with deriving different accounts. And there will be a separate video on building one proper transfer hook that does proper things, and then we properly do our own program for that. And maybe even work with Anchor, which is also not what we do here. So that's also a topic for another video, not today. So this video is titled Stuff We Do Not Today. But what we do today is getting this transfer hook to work again. So let's get this party started and deploy this program. For that, we need some Devnet sol. Airdrop me 10 sol. No, that would have been fun if that worked. 5 sol. Why did I get a signature and then it tells me balance unchanged? It called the memo program, probably something like you requested too much. Oh yeah, request too large. Cap is 5, and then after it tells me that, it's like, oh, your limit is reached. You've already requested something. God damn it, Devnet freaking faucets every freaking time. Gotta go to freaking Discord again. Insufficient balance. Okay. Helios. There we go. Thank you. Damn you, motherfucker. You're just giving me one. One? Don't pretend like you're not rich enough to not give me more. What the? Request failed. How is it so difficult still to get Devnet sol? There we go. Now we wait. This is my faucet. Twitter. Actually, 5. Confirm. Airdrop was successful. Oh, was it? Nice. Okay, so faucetsolana.com seems to work. Good, never tried that. So we have enough sol for deploying a program. Isn't that amazing? So we can just be like, oh, actually, I want to have a custom program address like hoots. That's my program. Deploy. Program ID is my hoots. And then the program itself is somewhere in target. Deploy SPL transfer hook example SO. Let's go. There we go. Easy. And my balance is now 10 sol because apparently somebody sent me some. Thank you, whoever was that. Thank you. Thank you very much, MD Dev. And now I have 17 sol because somebody else. This is a good strategy. I wish that would work with like mainnet sol as well, where I just post on Twitter, hey, send me something, and people send me something. Wow. I'm literally crowdfunding my Devnet wallet. Great, but I don't even need that much sol, but I have it. Great, so I can deploy several programs today. Amazing. Let's actually see if that hook program actually works as a hook with the interface. To also recap that, how that went when creating an actual token. So let's get ourselves a token. Tony LC. Nice name for a token. Create token. Let's create Tony. But with the program transfer hook, we put in our program. That should be good, I guess. 9 decimals and stuff is fine. Okay, Tony was created. And then the important thing is that not only do we need the transfer hook, we also need to initialize it because it needs to create this extra account meta list. And that initialize we can do with a set transfer. No, wait, that's not that. There, create extra metas for the program ID, the mint ID, and then that stuff. And in our first version, we need nothing. So, wait, do I have that already? No, I don't have that. I will also need to compile that, but that's part of the CLI, I think. If I build this SPL transfer hook, nice. Then I should have it in debug. Debug. There's the SPL transfer hook. Amazing. So all I need to do is SPL transfer hook. There we go. And that will work. So that has literally one command, which is to create extra metas. And it takes program and mint. Our program was the hoots and our mint was Tony. And we don't need any accounts yet. And this is the part where we're gonna discuss stuff today. That's where the more complicated stuff will come in. But for now, none of that complicated stuff. Just create that account just so that it's there. I will just initialize this account there, that PDA derived at 4 p.m. We see that 0 additional accounts are allocated, and that's fine. But this account needs to exist for all of this to work. And now that it exists, we can SPL token, create account for our Tony, and then mint 1 Tony. Now we've got 1 Tony in our wallet. And if we now SPL token transfer, whoa, I'm getting more and more rich. 37 Sol. Guys, I have enough, but thank you. Well, thank you, whoever that was. You shall get a Tony, because everybody wants that. I know everybody wants a Tony or 0.1 Tony. There you go. You can have a Tony. I will fund it for you because I can afford it, because you sent me 20 Sol. There we go. Wonderful. Wonderful. First of all, this is ridiculous. But secondly, the classic, we've had that. We definitely saw that error before. That's basically blah, 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 not the correct account. Which means the CLI doesn't put in the correct accounts. But that is probably because we use the CLI in version 3.2 and we don't use the proper CLI of like SPL token. So cd CLI and cargo build this. There we go. And now we should also have the SPL token. Wonderful. We can use said SPL token to do, well, pretty much the thing that we just did here, to transfer Tony and all that stuff, but with a CLI that we just built. And that works! See, there we go. We just need to use the correct CLI. Amazing. And we don't need to build ourselves our own script that does that like we did last video, because the CLI can actually do it. You just need to have the right version, which is 3.3 or up. Okay, so with 3.3 we can actually send those tokens. Can send Tony around. There we go. We're sending Tony. And we should see that somewhere down here, the token 2022 program. Wow, Explorer even says that it's that program now. Crazy. Making progress. This is still wrong though. I prefer to look at it like this because, let's be honest, that's more accurate. Because what do we have here? Well, sender account, token, destination account, me as the signer, so the authority, and then the hook program, and then remember the 4pn, that's the config, the extra account matters PDA. It's not multisig, forget that. That's just incorrect. And then we see the inner instruction to our unknown program, to our hook, our who's. Who's 7 with KP. And in the logs, we will read that, thank you for using our transfer hook. Hook completed. Perfect. So that works. Our transfer hook actually works. It doesn't do much, but it works. All it does is thank us for using that hook. Except it does one thing, and that is preventing me from sending 0 tokens. So if I'm like, well, I send you 0 tokens, then custom program error 0x45, transfer not allowed. Which, and I documented this greatly, the error for when the transfer should fail. Invalid transfer. 0x45 is of course 69, because 0x40 is 2 to the power of 6, which is 64, plus 5 is 69. So the 0x45 is this error. Just so I don't have a 0x0, because that's something that you should connect with something else, which is the correct account already in use. Cool, but that works. Isn't that cool? So we see what should happen when the transfer is not allowed. Already the simulation fails, because obviously the hook is gonna fail the entire transaction, and therefore it's just never gonna go through. Cool, so that's our version 0. That's as far as we got last time. Just as a recap, on how to create a token with a transfer hook. Just been over an hour of recording, so we're perfectly in time to build 5 more. This is gonna be a challenge. But anyway, it's gonna be super easy to do that, right? Let's get to version 1, where we still don't need further accounts, but we are gonna take accounts into consideration. What we already took into consideration is the amount, so how many tokens were transferred, and that is instruction data. And we can do the same with the given account data, because you see here our program is actually being called with source account, mint destination account, and the signer. So all those accounts we can reference already. And in our program here, we already do decode them. We already get the source account, mint, destination, authority, and extra account PDA. And we could just use that. So we could do a transfer hook that is dependent on, I don't know, the amount in that destination or even in the source account. Yeah, so let's create a transfer hook that lets you spend only half of what you have. Because why not? That's a great transfer hook, right? You never want to be able to spend more than 50% anyway. So that if you want to send all of your tokens, you need literally infinite transactions or something like that. Okay, anyway, so you may question the legitimacy of those transfer hooks that I'm building today, but it's more examples. Like, I want to show you what you can do with fun little examples. I'm not saying that this is actual useful transfer hooks. So anyway, let's check the source. So how many tokens are in there? And for that, basically, I just need to read state. So account stores the mint, the owner, and the amount. So we've got 32 plus 32 is 64. And there might be an account discriminator here as well. But let's see. So that's 4, 8, 16. So this one is a public key. This one is a public key. And then this is the amount. There we go. Haha. Exactly. With 9 decimals. So that's 0.9 tokens that I still have in that account. Perfect. So there is no discriminator in the beginning. It's just a token account. After the 64th byte, there's the amount. We need to know that because we want to read that, because we're using Rust and we'll need to manually decode that. When we're using Anchor, then it will probably do that for us one way or another. But for now, we're gonna just work with the data. Can I directly get a slice from you from like 64 to 64 plus 8 bytes? It was a U64, right? Yeah, that's 8 bytes. Then I want to use 64 from that as little endian, and probably that should work. Let's log it. And I could calculate that with decimals taken into account, but the decimals I would need to read from the mint account info. I could also do that because we know where it is. The mint has the decimals at this position, but I'm too lazy and it's not really relevant for us anyway what the actual amount is, like the UI amount, because we just want to allow that half of them should be transferable. So if the amount is larger than half of what we have in our source, then transfer exceeds transfer limit. So yes, I could make different errors here now, but I'm too lazy. But yeah, that's pretty much it. Let's check that. Oh, from little endian bytes is what I want. REST analyzer, why do you not tell me this? I mean, I would really like to just see this already before needing to compile it every time. What's going on with you? So I try into and then I unwrap. By now I'm pretty confident with Rust. In the beginning I was like, what does that even all mean? And now I'm like, yeah, of course. So that thing converts me this slice to an array because I need an array. I know it has the right size because that will always be size of 8. And then the unwrap, because this gives me a result. So it could fail that that has the right size, that it cannot convert that. And then the unwrap will just fail. But otherwise it gives me the result. And then the result I can use in here for the from little endian bytes. So that should work now. There we go. That works. And the Rust Analyzer also does work. Whoa, look at that. Because if I wouldn't have that, Rust Analyzer, would you tell me? Yes, you would now tell me. Yeah, mismatch. That's what I like. I like that. Amazing. And with that, it should work. Okay, cool. Fix the Rust Analyzer, which makes dev experience much nicer. Okay, moving on to, well, now that we have that, we can deploy that program. Then transfer Tony again, but let's transfer 0.5. Let's transfer half a Tony to that guy. And we will see that this will not work. Oh yeah, because of our 0x45. Or 0x45, let's be honest, it's 69. Tokens in the source account. Oh, I made a mistake already, but also it doesn't work. But it's good that I made that mistake, because then I can reiterate what's happening here and explain some more stuff. So it's good that we have printed those logs, because otherwise I would be like, yeah, that's expected, right? This doesn't work. And then I would have probably tested the other thing and that would have worked. And then I would have been like, yeah, it works. Whereas actually it does not. So the thing is, that's the amount of tokens after the transfer. Because the transfer hook, remember we talked about that last time, is called after the transfer occurred by the token program. So token Z does the transfer, changes all the state, and then we can check if that is what we want. So this here, the source account amount, is after the transfer, which means to get that idea of we are only allowed to transfer half our tokens, our check needs to look the following: if the amount is larger than the remaining amount in the source account. Should I call that remaining amount? So if we've transferred more than what is left in our account, then we transferred more than half. That's the logic, right? Could also be like this remaining plus the amount that we transferred, and then check that the amount is like larger than half the initial amount. But I find that is a clean solution. If I now transfer, it shouldn't work, but also the logic behind it should be correct, because the remaining tokens in the source account is 0.4, and I transferred more than that, 0.5. But if I transfer only 0.4, then that should work. Yeah, now we transferred 0.4 and the remaining balance is 0.5, and this is still bigger than this. So the transfer was allowed. Pretty stupid transfer hook, but it is a working transfer hook. There we go. That stuff is working. We can work with both the amount and the source account information. So all the state that is in the source and destination account, all of that information we can access, and also all of the mint information in case we ever need that. And also the authority. Like we can find out who is transferring, and we could do a blacklist or a whitelist or something like that. But there would need to be a hard-coded whitelist or blacklist unless we add an additional account, which is what we're going to do next. So that's version 1. We now know how to access the data in those accounts. But that just uses the accounts that we have in the transaction per default, which is, to reiterate, source account, destination account, and the authority. Oh yeah, and the mint. We can always access those accounts. And then we have this additional account, this one, that saves what other accounts we want. Watch that previous video on transfer hooks. I can't link it twice, I'm sorry. But yeah, we talked about that in the token hook video already. I don't want to go too much into detail, but actually we should reiterate here a little bit and have a look again how that stuff is derived. Just for myself, because I also forgot. Because now it will get interesting. So the transfer hook accounts. Additional accounts required for a transfer hook. Additional accounts with known field addresses can be passed at the command line in the format pub key and role. Role must be read-only writable, read-only signer, or writable signer. Okay. Additional accounts require seed configurations, and that's what we will want, can be defined in a configuration file using either JSON or YAML. Okay, cool. Let's try that. Let's define them in this JSON or YAML format such that we don't need to write code like this. Because again, we could do it with TypeScript, but if the CLI supports it, I guess I want to try that. Yeah, I'm more confident with JSON, so let's do JSON. I want only one public key. I mean, my idea was to derive it with just a literal, but that would already be using seeds. So as a first step, actually, let's do this without seeds and a static pub key. So forget that extra methods for now. Tre28. So this will be my treasury because I have a bunch. I got another 10 sol from someone. Thank you, whoever sent me another 10 sol. Totally getting rich here. So Solana transfer to the treasury, send 1 quick sol. Just so that this account exists and we don't run into errors of sending too little there. Watch my video on common errors if you want to know why I'm so concerned about that. And so basically now my idea is I want to build a transfer hook that enables transfer fees, but not denominated in the token itself, but in sol. So for instance, every time, and I know that you shitcoiners probably want to know how to do exactly that use case. Every time you do a transfer, you need to pay some sol to a treasury wallet. That's the use case. Let's build it. I'm gonna get rid of that stuff. And we don't want to check if somebody donated to a wallet. No, that's way too complicated. We want to actually do the transfer ourselves. So basically, we just invoke the system program to do a transfer for us. Transfer from the system program. We transfer from the authority. We transfer to, and this is now the interesting wallet. This is our treasury that we get in the same way. So first we get the extra account matters, and then we get the extra accounts, in this case our treasury. So we make sure that there is another account. If we don't get another account provided, then this is gonna fail here, and we'll have a look at that. But let's assume that we did that correctly. We set it up correctly with this additional account. Then we should get the treasury info, and we can use that down here. And then we say, whatever. What is the cost to transfer? I'm going to make a constant for that. I don't know. I mean, 5,000 lamberts is a transaction fee. So 100,000 lamberts. Freaking, there we go. And then we do the transfer fee in lamberts. We'll see. We'll see if that builds. So this thing gives me an instruction. So let my instruction be this. And then I build a version transaction. Oh, hold on. No, I don't build a version transaction. I'm not doing front end. I'm just invoking. And I don't need to sign myself. So I just invoke because that guy is signing already. So that's fine. And I invoke with this instruction count info reference. Let's see how easy it is to build that. I think it's sender receiver and that's all there is, right? So authority, I guess I'll need to clone that, and treasury. And then if that doesn't come back, then I raise the error. So the question mark here is not to be ignored. That's an important step. Only if that transfer completed will the hook go through. So essentially, I'm transferring myself 100,000 lamberts to the treasury. So this guy needs to be a writable account. Doesn't need to be a signer, but it needs to be writable. So that's what we will need to put in as our extra matters. And we didn't do that yet. And we will see it fail because we didn't do it. So let's rebuild it. What? And somebody else sent me 100 sol. Well, thank you. I'm getting so rich here. It's crazy. But I just want to deploy this. At least I will have enough sol for the next few videos. So the hook is deployed again. Now if I do a transfer again, even if I just transfer 0.1, this should now give me that weird error again with the... No, not that weird error, but this one. Insufficient account keys for instruction. That's my program that tells me that already. Why does it tell me that? Because of this question mark here. Because the treasury account, the next account info, That thing, that will give me exactly that error, insufficient accounts for keys. That thing expects another account, my treasury account, but the treasury account was not provided. Why was it not provided? Well, because the CLI built a transaction that didn't include it. Why did it build a transaction that didn't include it? Well, because it wasn't in the extra matters account that it fetched. So we need to put it into that extra matters account. And I don't know if I can update that account for a token that already exists. Oh, update matters. That's what we need. Oh, cool. That's new. Update matters. Update the extra account matters account for a transfer hook program. Amazing. We're going to use that. Let's use that. And that needs the program and the mint. And then the transfer hook accounts as usual. Okay, perfect. So update matters for who? And then our Tony token. And then we add a static PDA, namely our treasury. This one needs to be writable but not a signer, so just writable. I think that's how we need to put it in. Let's see. Looks good. Transaction coming back. Let's check it. And we see that we allocated some more space for this account. And then our program was also called with that instruction for the update the accounts, update extra account meta list. Nice, because it has update extra account meta list. Is that new? Did we also see that last time already? I'm not sure. I have that imagination that that wasn't here last time, but maybe that's an imagination. I have no idea. Anyway, we can update the extra account meta list, which is great. Would be weird if we couldn't. So basically, we now added one extra account. Somewhere is the type and somewhere is the 32 bytes for the public key, and that's pretty much it. Now that we have the updated meta, let's see if we transfer, if we still get that error that we don't have enough accounts. No, but we get a different error. Cross-program invocation failed. Unauthorized signer or writable account. Okay. And is writable privilege escalated. Oh, is that a check that it... Oh, right. We're learning stuff. So, apparently, for security reasons, the hook program doesn't get the authority account as a signer anymore. I think that's my problem now. So, for security reasons, wait, that's a different instruction though. Hold on. Here but I do get that as a signer. But let's check if that's actually true. Writable and is signer is writable. Is signer. So deployed, let's see. There. Authority is writable, false. Authority is signer, false. Damn! We don't get that as a signer. So it's not that easy to just transfer from that account. Security. Who wants that? Actually, probably a good thing that it's not so easy to just steal all the lamperts from within a transfer hook. So actually probably smart. I just wonder where that happens. But I think the token program does that. The token program, before calling the transfer hook, actually removes those privileges from the authority, such that the authority is just read and doesn't sign. Oh, too bad. But if it was a legit use case and the user also wanted that, can I do that? I mean, I could set up a temporary account for that authority, but then I would need to manually fund it. But yeah, as a first solution, maybe let's do that. I do want to get a working transfer hook, though, with just one static account. So instead of it being a treasury wallet, let's do the opposite. Let the treasury fund the authority. Let's get some SOL for doing transfers. Because that's definitely not something that you want to do. You think I can provide additional signers for the CLI? So I have two possibilities here. Number one, I make it a PDA. And the second one, I just add another signer. So I would update this again and say writable signer. So then we get pretty much the same thing here. There's probably the pubkey again. And then we have writable and signer, the two booleans, or signer and writable. I don't know which one was 0 last time. But yeah, now it's writable and signer, this one. So if I now execute a transfer, it will probably already complain here is not fully signed. Yeah. But how can I tell the CLI that I want to add another key pair? Can I do that? I can provide the signatures, but I just want to provide another key pair. Can I do that? I mean, one quick hack would be that I let my Treasury wallet fee pay, because Treasury wallet will also sign. Let's let it fee pay, but send the tokens still from the other account, from the Andy. Let's see. Yeah, then we still get the same writer privilege escalator. Okay, cool. But we can call it. Then Treasury is writable and signer. Then I would switch those around. We send from the Treasury to the authority, and also here from the Treasury to the authority. The transfer fee in Lamperts. Lol. Let's see. Build that. Deploy that. Do a transfer. Oh no. Cross-program investigation still with unauthorized signer or writable account. Treasury is writable and is a signer. Treasury is writable and signer. Then I still get a writable privilege escalated for ND. Oh, I can't transfer to you either because you're not writable. God damn it. That's just ridiculous. Wait, but I shouldn't need writable privilege to send Lamperts. Okay, no, I do need writable privilege. Obviously, I'm changing the Lamperts. Yeah. But I don't need to sign for that. Ah, that's annoying that it just steals me the right. But this, I mean, come on. I cannot even, security is good and well and stuff, but I can't even send that poor guy some Sol because he's not writable anymore for me. That's just stupid. Come on. I'm gifting them some Lamperts from my program. Come on. I'm starting to not like transfer hooks as much as I thought I would. I still like them. They're still great. But that's just, come on. Come on. You steal me my writable. Can't I? The poor sender. Can I get the sender in the list of accounts again? No, I cannot, because I can only derive it from the authority or the destination account or the source account or the input or whatever. But it's always a derivation and never the straight account. Well, actually, oh yeah, I can do the straight pub key. That's what we've been doing with the Treasury. Wait, yeah, but then it's one pub key and it's not dependent on the authority. I can put the authority there, but then again, it's one pub key. Oh, this is annoying. Damn. What I could do is get a charity 3 bar for real. And I could just put that charity as another key. So I update that I want the Treasury and I want the charity as writable. And then whenever the transfer occurs, we send from the Treasury to the charity wallet. So whenever you do a transfer, the program Treasury sends to that charity. That stuff I could do. So if I now transfer some tokens, of course I gotta build and deploy the program first. What? An account required by the instruction is missing. Oh, of course. The account infos will require the system program. The system program is not part of our accounts, but since we're just doing static accounts anyway, I can just add it. But that also means that we need to add the system program as a read only. How would I need to write that? Read only. Do we now have the system program? Better. We execute, then the program is invoked. Oh, that looks already good. And the system program gives me a success. And then thank you for using the transfer hook. The hook already completed. But then success, token program success. Why did it fail? The transaction results in an account with insufficient funds for rent. Yeah, I thought so. Because 100,000 Lamperts or whatever I sent there is not enough for rent exempt. But I don't want more than 100,000 Lamperts with every time. So the quick solution is to just fund the charity wallet up front. Transfer to the charity, I don't know, 0.1 Sol. I still have enough, let's be honest. I still have enough. People keep sending me Devnet Sol. Not Sol, but Devnet Sol. I mean, Sol would be even nicer. Next time I'm gonna write, I'm having problems getting mainnet Sol. That would be amazing if I would get as much there. So, anyway, if we now do the transfer again, now it should work. And it should also actually send a little bit from the treasury to that charity wallet. Let's check that out. So that treasury was the fee payer. Andy also signed, rich guy. And the charity got 100,000 Devnet Sol. Look at that. It's rich now. Yeah, and basically every transfer will now fund that charity wallet a little bit. And that's my version 3 with static accounts. We've been using 3 static accounts where we just enter the pub key, like this, a pub key. So yeah, this is our version 2 transfer hook that transfers from a treasury to a charity. But both of them are given as static accounts, which, especially for the treasury, is super weird because the treasury also needs to sign. So you need to have the treasury wallet. Otherwise, you cannot do that. So essentially, that's so stupid. It's so stupid. Essentially, you need to have 2 wallets just because the stupid transfer hook doesn't allow the authority to stay writable and stay a signer. So you need to put in another treasury account with which you actually sign to pay for this. So again, if you don't have the treasury, you can't even transfer if you don't have the treasury key. And the treasury should really be an account that is derived from the program and not a key pair that I hold. So let's change that a little bit. Let's make the treasury actually a treasury from the wallet. So let's rewrite this a little bit. For now, what we had, the treasury wallet as a writable signer. Then we had the charity wallet as writable. And then we had the system program as read-only. So that's what we had so far. Essentially, if I would update instead of this with this file here, then it should have the exact same result. So if I were to say extra matters, that should essentially do the same thing, just that I put in the extra matters from this JSON format and not just from CLI arguments, but it should still be the same. So I should still be able to, transfer 0.1 tokens and that stuff landing. There we go. And the charity getting funded a little more. Okay, that's static accounts. They don't depend on any of the user input, unfortunately. I wish I could make that dependent on the freaking user, but I can't. Damn stupid freaking transfer hook. Taking security seriously. Shit. What? Yeah, it's always a trade-off between, security and featureability. No, the more you can do, the easier it is to exploit. The safest would be not to be able to use the authority at all and not even read who sent something. But then, that limits you even more. Anyhow, let's get that treasury not a fixed pub key, but a key derived somehow. This is seed, yo. As a first one, I would like just static seeds. We will again have basically a static account, but it's now derived from seeds. And from which seeds? Well, treasury. And then here you expect a reference, another pub key. Sure, let's borrow. And yes, I'll copy this. This is not the nicest thing to do if I copy this here, but whatever. It's just debug anyway. I'll remove it in a second. Okay, so let's build that bash script. So redeploy. Perfect. Let's do such a transfer again. And since that succeeded, we can look here. We did some printing. We're using those seeds. So that's basically just treasury as a literal. So as bytes here. And that results in the following PDA derived from my program. So that's a PDA from the hooks program. Huzzah! But anyway, this is what I'm interested in right now, because I want to fit that into that thing so that basically that literal says treasury now. I'm providing this as bytes, and that whole thing should be a writable signer. Hold on. No, it's just writable. The signing comes from it being a PDA. Let's see. And now I would be interested if I now update it to this extra matters 2 JSON, so this one where it has those bytes. If I now transfer a Tony, I don't need a specific fee pair anymore. That shouldn't be required now. But then I get a custom program error. Do we know what that error is? Nothing. Nobody in the history of Google ever had that error. Okay, this is where I'm getting a little stuck now, must admit. So I guess we'll go back to calling that stuff myself and not with the CLI. Yep, okay, let's try building it ourselves. Why not? Gonna borrow that script from last time. So we go to Devnet, we have our key pair, we have our mint, that was Tony. We'll stay with this guy as our receiver. And then here comes our stuff. So we got the source, mint, destination, authority, and then the program ID. Then that should be our derived extra matters. Does that need to be writable though? But then we need 2 more. 3 actually. One is the static charity that needs to be writable. And the other one is the freaking system program. And then the last one, that will be our freaking treasury PDA. And I'm not sure if that's derived correctly. I'll just put it in like this and we'll just see where this goes. And then I probably also want to change the instruction data a bit there. These, because this is 0.1 tokens. I can't be bothered to encode that properly. I just always transfer this. And yeah, then we get a block hash and we send and confirm. I mean, so far so easy. Let's check. Oh, did I leave a space somewhere in there or something? Yes, I did. Okay, try again. Privilege escalation. Oh, wonderful. I get something. But hey, that's something that I would expect actually. A privilege escalation. That sounds exactly what should be happening because, let's be honest, I'm still trying to invoke this without the treasury being a signer. Just want to have this log real quick. So the treasury is writable, true, but the treasury is signer, false. And that's the treasury. So I'm putting in the right thing as a treasury. So that already works, that I'm putting in the accounts correctly. But, I'm putting in the accounts that I expect. I'm not sure if it's actually using those seeds. So if it, but no, it must be, because otherwise it would not have put that account in that order in there. So I guess that's already working then. Which means if those are the actual keys, then I can actually use that program and that actually made it all the way in there. That means I can use this treasury here now and do a invoke signed where I then also provide them seeds. I mean, yes, I have duplicated code again, this and this should be the same, blah, blah, blah. But that was also just for check. I could comment that out and then it's not duplicated code anymore. Before we do that, we gotta redeploy. We get a warning. Because unused import. Well, that's fine. Okay. And then transfer again. Transaction privilege escalation. Do I skip pre-flight checks or something? I'm skipping pre-flight checks. That's why. Well, actually, how about I don't skip pre-flight checks and then I don't need to manually simulate it first. So failed to send transaction. Cross-program invocation failed. Okay, so apparently I'm not putting in the right seeds here or something. This should match this, which it does. We're checking this. This is the PDA and this is the PDA. It's the same account. So if I put those bytes here, you should set this treasury as a signer. But here I'm invoking a system program, signer's privilege escalated. Okay, so something is not working with my invoke signed. It's probably a super simple issue that I have. Oh, the bump, of course, the bump. Of course, the bump. Of course, the bump. You forgot the bump. Okay, gotta give the bump. Baila bumpa, baila bumpa, baila bumpa, baila bumpa. That was it. I tell you, that was it. Just redeploy this now and then it will work. That's how happy I am if I found a potential fix to my bug. And also, I just love music. In case you couldn't tell, I really do love music. Go for fuck's sake! Maybe that's still the wrong. Maybe we still had to wait a bit. Oh, but that looks way better! Baila bamba, baila bumpa, taka taka. Nice, nice, nice! We now just have insufficient Lamberts. I mean, if we have 0 and we need 100k, then obviously that ain't gonna work. Why do we have insufficient Lamberts? Well, because our treasury, the program treasury, is not funded. Yeah, that's true, but that's an easy fix. Solana, transfer to this pool treasury 100,000. No, I don't have that much. Wait, how much do I have? 161. I'm getting more and more. The longer this video gets, the more Sol I have. Usually it's the other way around, but people are being nice. Anyway, so let's transfer one of those sols to that pool treasury account. And now that that treasury PDA that belongs to the program, well, belongs to it, actually it's owned by the system program still, but the treasury program can sign for it. Difference. I also made a video on that sort of difference. You can also find that here maybe if I can be bothered to put it there. But now let's check that out. We get a signature! And if we check that signature, Andy pays, he sends the tokens, so he sends to that guy's ATA some Tony, over 0. I'm running out of Tony. But yeah, that transfer worked because the transfer hook was like, yeah, I sent that to charity, so you're allowed to do that. Yeah, that's cool. So with every freaking transfer, we're sending from the PDA to the charity. So that was the next step in our iteration of our transfer hook. We have an account that is derived from some static bytes. Because it's always the same account, it's always the same treasury account. So we just have some static seeds, but it is derived. Great. So it's not a static PAPK anymore, it's a static PDA. Cool. In fact, so cool that I'm gonna freaking git commit this. Version 3. Yeah, that was it was easy, but you gotta think about that stuff. Not forget the bump. And yeah, it's not a nice solution to derive it here like this, and it would be better to have that stored somewhere on state, whatever. Like if the treasury would actually be owned by our program and we could, like read the bump from there or whatever, would be a bit more efficient than this. But hey, am I gonna build an efficient transfer hook here? No, I'm gonna build a transfer hook that works. Speaking of transfer hooks, now we just did with static seeds, but we can do with, well, the seeds are always gonna be static, but the accounts are then gonna be dynamic. So as we learned last time, we can have the account depend on some string or numbers, but also on the accounts that are provided and even the instruction data. So hard-coded values, that's what we did so far. A slice of the instruction data, the address of another account in the accounts list, or a program ID. So either a program ID or any of the addresses that we already have in the list of the accounts. So this is the interesting part. Address of another account in the total list of accounts. And in that example, we already saw, here it already showed us for seeds that can be account key. And the index, that's a great question, what that indexes. It could be the transaction accounts, but that would be highly weird because the transaction can look very different. So I'm pretty sure that we're talking about the instruction accounts because the order always needs to be the same. So they are the ones that we're talking about here. So this would be index 0, this would be index 1, this 3, 4, 5, 6, 7, 8, and so on. So let's have a PDA. I mean, we could, as a first start, do the same thing that we did right now, just we use the mint to derive the treasury as well. So when our transfer hook supports several tokens, each of them should have their own treasury. That could be a valid use case. So let's do that. Additionally to the literal, I want account index 1. So what I would expect is that the derivation now looks as follows. Treasury PDA does not only take treasury as bytes, but also takes the mint info key, 2 bytes. And the rest for the program should actually be the same. Then in our transfer, we just need to put in a different public key, and I'm gonna derive it. Treasury is public key, find from treasury and mint 2 bytes, treasury PDA, treasury, and then I put the treasury here. The order of those is actually not that important. I can have the treasury and then the system program or whatever. It will find that in the right. We saw that last time as well. So, and then try and do a transfer. Again, we're not providing the right accounts. Oh, why? Well, because we didn't update. Yeah, of course. We also need to update the extra account methods to the 3rd version. What the fuck? Try help. Help. Oh, I need to put it in an object. Oh, got it. Such that, okay. So this thing, and here you need a different object with the account keys. That's what you need. That's how we need to do it. Okay. Well, then let's do that. Boom. Okay. And with those extra methods updated, when I now do the transfer, damn, still not cool. Maybe I didn't wait. I did in fact not wait long enough, but that looks better. At least we're not getting this annoying something, I didn't provide the right accounts error. Treasury 6Z. And then failed error processing instruction, failed to complete. Well, that's very verbose. And it failed to complete because could not create program address with signer seeds. Provided seeds do not result in a valid address. That's true. I forgot to update the seeds because, again, duplicated code that you should try to avoid to not run into exactly those issues that I'm running into right now, that I changed the seeds up here but forgot to change the seeds down here, which is why we're gonna totally make a variable now. Seeds be like, yes, a bit ugly, still ugly, but at least no duplicated code anymore. Seeds with bump, let's do that in 2 steps. Very good. That looks like almost clean code now. Wow, if that works, I would be very surprised. But yeah, so definitely more difficult code, but no duplicated code. Welcome to Rust practice with solandy. What are we fucking up here? Create a temporary value which is freed while still in use. So let's bind this. Let's not make it this. Let's keep it as a vector and then only do it as a slice down here. I just call it bumpy. Okay, again, that doesn't make the code any better, but it makes it compile. Yeah! Redeployed. And now that we don't have that duplicated code anymore, still have that problem. Damn it. And what was our problem actually? Instruction failed to complete. Could not create program address. Provided seeds do not result in a valid address. So we still have this. The treasury is this. And the derived treasury is also this. But we're deriving the correct account. What I did in the last half hour or so apparently doesn't work. Oh, apparently I didn't wait it long enough. Nice, that's better. Now it has the right version because it does work. It's just that insufficient lamperts again because my treasury wallet is not funded. A classic 0x1. Well, that's at least easy to solve. Just transfer to the poor treasury 1 sol. Then this transfer should actually work. It does not yet Because again, we just gotta wait a bit and be patient with the poor little transfer hook, or actually the RPC. But now, check this out. We get a signature. Amazing. Finally. Which, again, basically the same thing we sent to our charity from this new treasury that now depends not only on my transfer hook program ID and some static seeds, like a treasury literal, but also on the mint. So if it was a different mint, it would be a different treasury. So that was just an example where you should see how we can derive with several seeds. So with a literal and another address, any other address. And we do that by providing the account key here. So then it adds these 32 bytes from the public key of that address as seeds, you know? So when we do this here, index 1, then what's happening is that the index 1 account, so in this case the mint info, will be added to the seeds like this, and that's how that PDA is then derived, and that's the account that it expects here as the treasury. So that's what will come in here as the treasury info. It can still be good to, you know, double check that and assert that actually this PDA corresponds to what we are getting as the treasury info key. I could manually do it just in case somebody calls this instruction. If it comes from the token program, then we can be sure that it's that anyway because it's defined in that other account. But somebody might just call our program, like our interface, and pretend to be the token program or whatever. So we do want to make sure that we're not exploitable here. So if that does not equal, then I'm also gonna error invalid account data, invalid argument probably. Invalid argument. It's not the correct freaking treasury, damn it. But that's just double checking. Yeah, that's how we do it with an account that we derive. And I think we can end it here. I wanted to do one more iteration where we would do fun stuff like derive from destination and source account. But again, that's the same thing as with the mint. You just change the numbers here. Instead of index 1, you use 0 and 2. And then you can do stuff with those accounts. And I wanted to do fun stuff like deriving PDAs based on the amount, because you can also do that. I don't really see how that's a useful use case, but you can do that. I mean, I've been recording for over 4 hours. But okay, let's do that as one last thing. Let's do it. Just so you also see that. Account data. Oh. Even from account data you can derive stuff. So data that is in an account. Wow. Well, that's cool. So you can have an account that basically stores another pub key, and then you can use that pub key to derive. Nice. I mean, very versatile on what you can derive. I just still have the issue that it's all deriving with our program ID. So I can never have the user account. I want the user account. I want to have their pub key. But for security reasons, I'm not allowed to. That's probably even cooler than the instruction data. But anyway, we said as one last thing, we do this. So let's do this. And also add the instruction data. Yeah, why not? And the instruction data, which has at first the execute discriminator and then the amounts of lamperts. So if I want, for instance, the amount of lamperts, then I have to have an offset of 8 and a length of 8. Index 8, length 8. Sounds about right. Then that would represent that into our seeds we add the amount, 2 little endian bytes. Then we would have a different treasury PDA. That doesn't make any sense anymore now. We don't want to have a different treasury for different amounts. Let's do something else instead. Let's say each amount can only be transferred once for this token. That's our use case. Yes, that's what we're doing. Each amount is only transferable once. And if somebody else already transferred that amount, then you need to choose a different amount. So we're going to build a highly annoying token. And we keep the treasury, but not to fund the charity anymore, but to pay for other accounts. Because apparently I can't use the authority to pay for stuff in here, which is super annoying. Okay, anyway, so we get the amount out of those seeds again. And let's say amount PDA. Basically an account that we create when the transfer is completed. And if the account already exists, then we don't allow the transfer anymore. Because that's stupid. I'll rename this to my treasury seeds, and then I'll have amount PDA seeds, which is amounts, then also the mint, and then also the amount to little Indian bytes. A bumpy. Pile a bumpy. Pile a bumpy. Amounts seeds with bump is the... Probably have a copy paste error somewhere. Let's just quickly deploy this thing. Transfer this thing. Insufficient funds, of course. Oh, even from the token program we already have insufficient funds. Well then, SBL token. Mint me another Tony, please. Okay, but now. And now? But that even worked. For some reason I expected it to fail, but yeah, I didn't put in the part where that actually uses that other account, so... And also didn't update to use any other seeds, so it's still working, yeah. In the logs we see that we use those seeds, and that's the amount as seeds as well. So this is essentially what we need for the literal amounts. So let's build that properly. We said the treasury we keep like this without that. We remove this part, so we keep it as we had it. But then for another additional account, so a fourth account that we need here, we're gonna put this literal amounts. And then we're gonna put the account key, the mint again, and then we put the instruction data with index 8 and length 8, which is the actual amount that we're sending. And that one needs to be writable, yes, but it doesn't need to be a signer because it's our PDA anyway, so we can sign for it as a program. And then what we do in the program, instead of doing a transfer here, I mean, we can keep the transfer, but really what I want to do here is create the account. The from is the who pays, and who pays is my treasury, because the problem is I cannot pay as the actual authority because I'm not even writable there anymore. Not even that I'm not a signer. It's not the only issue. I'm not even writable. So I can't even send something there. This is so annoying, but security, probably a good thing. Anyway, so from here to here, that's the account we fund. Then the Lamperts. I mean, I could do that neatly, but the video is already so long. I just want to get it done. This many. The fact that the account exists alone is enough for me. I don't need to store any state. The state is that there are Lamperts there. If there are Lamperts there, then the account exists. And then that transfer succeeded once. And the owner, I'm going to make myself the owner. My program ID? Wait, do I have that? Am I aware of my own program ID? Yes, I am aware of my own program ID. Wonderful. So here we create the instruction. And then we basically do the same thing as before. Again with treasury info, but then amounts, and that we need to get from up here because we have an additional account now. The accounts PDA, and that accounts PDA we need here. And here we then use those seeds, and we can do it a bit nicer here instead of calling the question mark, because we will get a 0x0 back if it already exists, and we could do nicer. But actually, no, let's leave it at that for now, and we do nicer than later. Let's redeploy. It did compile, so that's already a good first step. But then I hope that I have the seeds correct. Speaking of seeds correct, obviously we now also need to update the extra matters to the number 4, which has this extra account in there. And then of course in our transfer we also need to put in that extra account, which we derive amounts, the mint, and the actual amount that we sent. So hopefully that will give me the same PDA then. And then we put that PDA also in here. Amounts PDA, writable true, but not a signer. And then let's see if we can transfer this. No, we cannot. Oh, we don't have the right accounts. So the amounts PDA would be this. Iowa. It expects a BEN5. Oh, shit. It expects something different, and I don't know why. Buffer from. Still same thing, still gives me the Iowa. Okay. Amounts. Is that correctly spelled? No! Ha! Ha! I mean, I'm a bit blind, but there is a difference. Emanut. Emonut. Yeah, I wrote. You probably saw that. I legit did not see that. I always read amounts because I cannot read. That's why I love video content, because I just cannot read. Written content is super hard to consume for me. Anyway, I found the error. I wrote emonuts instead of amounts. So, amounts then. Sadly, it's not Iowa anymore, but now, look at that. It at least had the same 8EN5T. Doesn't sound as nice, but it's the correct one. And then we failed because, of course, cha-la-la-la-la. The system program was even invoked correctly for the first time, so that's the transfer of the charity thing. And then we have a signer privilege escalated for who's signing here? The 6 said. That is in fact true. Yes. I got you. I understand you. Thank you, error message. That makes perfect sense because we are sending from the treasury wallet. So this one is funding that account. So we're sending Lamperts from there to there. So obviously this guy needs to sign, and we didn't provide the seats for this one. So we would also need to say treasury seats with bump. Actually, that's why we can provide here a slice of a slice of a slice of U8, such that we can have several seats. So here we sign for that one, and with those we sign for this one, and that should then fix this. Redeploy this, please. And now, if we do that again, then it will totally work and give me a signature. Come on, give me that signature. There we go. Look at this. We got a signature, which is great because now this account exists. There, this one, this 8EN5 something, which is fun because obviously if we do the same thing again now, it won't work anymore because 0x0, because that account already exists. It's already in use. And that's what I meant with we could write that a little nicer here. Instead of this question mark, we could say, can't really get that out. Anyway, point is, since we've already transferred this amount once, we cannot transfer it again. So our transfer hook fails on us. So we need to choose a slightly different amount. Like, I'll just be lazy and add 1 Lampert in the token thing. And here as well, 1. Or actually it would be here, 1. And then it would be a different PDA. So if I transfer a different amount, that's all front end now, then it works again, right? So I didn't change the program or the hook. I just transfer a different amount. See, it's different now, just for one tiny bit, but it's different, to get 69,999. And there it worked. Congratulations, you were the first one to transfer that many tokens. And then if I were to do it again, then obviously it gives me the 0x0 again, because the system program keeps failing because that address already exists. There we go. What a wonderful transfer hook. Okay, and that's enough for me. I gotta stop at some point. What a day. we've worked with transfer hooks. We saw so many things, like how we can build a transfer hook, how we set up the token that it actually uses that transfer, how we can then update the extra account methods. Like, first of all, set the extra account methods and then update them. And then how to use a static account as an additional account for your hook. How to use seeds for your hooks, both from accounts and from instruction data. We've looked at all of that and we've built some transfer hooks. Admittedly, those transfer hooks are not particularly useful. I mean, who wants a hook where you can only transfer any amount once? And who wants a hook where you can only transfer 50% of your token holdings? But that's all just examples that should showcase what is possible with transfer hooks and what is not possible with transfer hooks. For instance, we saw that it's not possible to get any of the lamperts out from the user account, or even get any lamperts into the user account, which admittedly can be quite an annoying thing. And now I understand the people who ask me, hey, can I somehow get an account in there that is not derived, but that depends on the authority? And I'm like, no, you can't. So yeah, transfer hooks do have limitations. They're still super powerful, but it's good to know all of those things, because transfer hooks really are in my opinion, coolest thing about Token 2022, or token extensions as we call that now, because you can basically just have any logic that you want. Might do a bit of workarounds to get some stuff to work, admittedly. You might need an additional signer, or you might need extra accounts for the user that they need to pre-fund for them to pay for stuff, but it is all somehow possible, even if not easy. Yes. And with that, I'm gonna end it, because this has been a very long video. I hope that it's like under 1 hour, 10 minutes or something. But like, I recorded for 5, so it's probably gonna be long. My brain is a bit exhausted. I need some sugar again. So I'm gonna have dinner, and I will see you in one of my next videos. You can check out the old ones. Here, by the way, you find the token hooks, that the first one, in case you didn't see that and watch this entire thing for some reason, missing the basics. Catch up on that one more time. This will not be the last video on transfer hooks. I will come back with more content, probably something like building the same thing in Anchor. I've never worked with a new token program with Anchor. That could be an interesting video. So yeah, make sure you're subscribed, like the video, and I'll see you soon.